Voy a comenzar. So, Jamaica's introduction to nuclear technology really began in 1984 when we got this Slowpoke 2 reactor. It's a Canadian design reactor, and it's achieved criticality for the first time in March 30, 1984. The reactor is 19.86 percent uranium-235, and it is primarily used for neutron activation analysis as well as education and training. It is located on the university campus of the West Indies, and it is the only nuclear reactor in the English-speaking Caribbean. So under the projects and supply agreement, this was signed in 1984, we were able to acquire the fuel. This was an agreement between the government of Canada, United States, and Jamaica, which entered into force on January 5th, 1984. Now, this agreement was terminated on September the 4th, 2015, according to Article 12, Paragraph 2 of the agreement, because we decided to change the core of the reactor to low-enriched uranium. So a few reactor core specifications. So the reactor is 20 kilowatt. It is a small reactor with uranium dioxide fuel and enrichment of 19.89% uranium-235. The reactor, as I mentioned, is used for neutron activation analysis primarily, with a maximum thermal flux of 1 times 10 to the 12 neutrons per centimeter square per second. So I think most people here would have been familiar with this technique, and this slide shows the basic principle of neutron activation analysis, where an incident neutron hits a target nucleus in the sample, and this produces a delayed gamma ray, which is characteristic of the element in your sample. So we've used this technique to analyze different sample types. So here at iSense, we use what is called the relative method. So typically the sample matrix along with the appropriate blanks and certified reference materials, they are all irradiated simultaneously and later measured under the same conditions. So this is one of our irradiation control here, and we have 2 of these at iSense. So we also have other complementary nuclear analytical techniques that we use along with neutron activation analysis to do our research. One of them is EDXRF, which is very convenient analytical technique, and it's multi-element, and it is particular for elements not convenient for neutron activation analysis, such as copper, lead, magnesium, nickel, phosphorus, and potassium. We also have total reflection X-ray fluorescence, which is also elemental, but this is more, we can achieve better detection limits up to parts per billion. And we also have a portable XRF analyzer, which can be taken into the field and can be used to get a quick information about the soil. So this is a geochemical atlas of Jamaica. This was one of our first major projects that we did in the 1980s into the 90s, pretty much. We went around the island and collected went to about 165 sample sites, and we did this for about 32 elements. So as you can see, this shows the variation of the concentration of the different elements, and we are able to determine what were some of the levels of some of the hazardous elements in the Jamaican environment. And actually, we found that Jamaican soils have elevated concentration compared to other countries in the Caribbean and even worldwide. And this is a very useful map because farmers can use this to determine whether it's safe to grow their plants and stuff in a specific region of the country. And we still use this as a baseline when we do analysis even now. So using neutron activation analysis, we have done a variety of studies. One of them is looking at mineral composition of food. So we have done pioneer research on mercury, selenium, and other elements in lionfish, for example. We have looked at elemental composition of Jamaican food, looking at different types of vegetables, root crops, and we've done dietary intake of minerals and trace elements in rice. also use the reactor to do things such like forensics. So we had this case many years ago where we had a suspected stolen beach case. Yes, where some truckloads of sand was removed from one beach and taken to another beach. And so we use neutron activation analysis to do some elemental analysis and try and fingerprint whether the beach was stolen or not. And this was actually quite successful. We've also used neutron activation analysis to look at the source provenance of Jamaican cannabis, trying to identify where a specific cannabis is grown in the country. And so these are some of the forensics type of work that we've done using neutron activation analysis. We've also used neutron activation analysis to look at the provenance of Jamaican coffee, because Jamaican Blue Mountain coffee is a high valued product. And so we want to make sure that it is not being counterfeited. So what we've tried to do is to once again fingerprint this product by doing elemental analysis and trying to look at how the elements, the factors of the various elements. We've also used neutron activation analysis to determine trace elements in sargassum. In recent times, sargassum has been somewhat of a problem because we've seen it showing up on a lot of the beaches. And so we want to know if this can be used to do other things. So we've done grab sampling of marine sediments for analysis of trace elements to determine pollution indices. So throughout the country, we have several medical institutions where we now are increasing our capacity in terms of diagnostic imaging, as well as nuclear medicine. In 2002, we opened a new nuclear medicine center that will provide life-saving diagnosis and treatment of non-communicable diseases with the support of the International Atomic Energy Agency under its Ray of Hope initiative. And this will help to fight things like cancer. So one of the next big project that we're looking to endeavor in is using our gamma irradiator, which is set to arrive in the island this year. And one of the primary things that we want to use it for is the sterile insect technique, which I'm sure most people are familiar with. So we wanted to use it to fight the Aedes aegyptus mosquitoes, as well as other projects such as plant mutagenesis and food irradiation. So as I mentioned, one of the other projects is to improve the crops using experimental gamma ray treatments to enhance production of crops, as well as, so in the medium to long term, this facility will not only allow the sustainable implementation of both projects, but will also allow the application of technology in numerous other crops and vectors, both in Jamaica and in other countries in the region. So there are further applications that this gamma irradiator could be used, and one of them is the shelf life extension, looking at pathogen reduction, as well as insect disinfestation, as well as research for sterilization with healthcare products. So in recent times, the government of Jamaica has announced its intention to explore nuclear power. For almost 40 years, we've had a nuclear reactor, but we've only used it for research. But now we're looking to get into nuclear power. And so whilst we have a lot of renewables in Jamaica, it's always, sun is always shining, we have a lot of wind. This offers a lot of advantages, but there's still a number of disadvantages, such as unreliability and low efficiency levels. So nuclear power could be a solution. This nuclear power could address the issues associated with renewables by providing a stable power to support economic growth. And it is noteworthy that the price of electricity from nuclear power is competitive with renewable energy sources. And so one of the things that we are considering is that if nuclear power is to be a viable option in terms of Jamaica's energy mix, it will most likely come in the form of small modular reactors. The relatively low initial capital costs, manageable size, and modular nature of SMRs makes them very, very suitable for developing countries such as Jamaica. So, and moreover, the unique attributes such as the expected efficiency, flexibility, and economics may position them to play a key role in the transition into clean energy as a part of our Vision 2030. So the question is asked, why now? Why we didn't explore this before? Because simply conventional technology, nuclear power technology was simply too big for our grid. Jamaica is a small country, and as you know, the initial setup cost for nuclear power is very, very high. However, now with the development of SMRs with over 80 designs worldwide, it is now a part of the conversation. We can start considering this because the initial startup costs will be much less and it will be more suitable to integrate into the into Jamaica's electricity grid. So we will do a comparison of SMR versus conventional nuclear power plants. Small modular reactors have much lower startup costs, as I mentioned. There's operational flexibility, increased safety features, and reduced fueling requirements. So some SMRs are designed to even operate up to 30 years without refueling. So when we think about waste management, that might not be a big issue because we don't have to refuel the reactor for 30 years. So we know that with renewables, the sun is not always shining or the wind is not always blowing. So nuclear power could work in tandem with renewables to offset this. Hybrid energy systems simultaneously address the need for grid flexibility and greenhouse gas emission reduction while optimizing financial resources. So while nuclear power plants are dispatchable sources of energy, they can actually adjust the output according to the electricity demand. So nuclear energy really seems like a great option. Gracias por su atención. That is all I wanted to share.